Here's Precalc. It's lesson 3.1.2. I made a little lecture because of missing class on Monday. So if we would have been in class together, we would have done a 3-20, and it's just about how to simplify complex fractions. And so I'm going to show you, there's more than one method, but I'm going to show you a method. Okay, so one method for simplifying this would be to clear the little fractions, because this method works great because I could multiply the top and the bottom by just by x over 2. Sorry, x plus 2. So like if I multiplied this by x plus 2, I'll go like this. The x plus 2's cancel out right there. And then that one would just give me 3 times x plus 2, right? But if I multiply the top, I have to multiply the bottom. So I would multiply the bottom also by x plus 2 over 1. And that would give me over here 8 times x plus 2. And then this x plus 2 and this x plus 2 cancel out. So I'd have minus x times x plus 2. So, minus x. So basically this one right here, we canceled out the x plus 2, and then here we have 3 times x plus 2. And then over here, that says x plus 2, believe it or not. So that gives me 8 times x plus 2, and then here we have a cancellation. And so then we can distribute. And so we got 3 times x is 3x, and 3 times 2 is 6, and down here is 8x plus 16, and then there's the minus x. And then you combine like terms, and here's your answer. So that is the easiest method. Multiply by something that'll get the little mini denominators to cancel. Okay, that's your method. And then, next time I see you in person, we'll have you practice on a couple problems. The next concept that is in this lesson is advanced substitution. And last year it was called Graciella's method, and that's because there was a problem in the Integrated 3 book where Graciella was trying to simplify a problem, and she came up with this method. So this is also called U substitution. So we usually try to use the letter U when we do this substitution, but really, like for my Integrated 3 kids, I just use the letter A, because U's are, I don't know, sometimes they morph into something else that was not intended. So you can use any letter of the alphabet. Okay, so your book kind of guides you through on 3-22. It says one of the teammates suggests rewriting the expression as 9u squared plus 3u minus 2 to make it look easier, because that looks like something we'd be able to factor. So if that's the way that we're going to rewrite it, what does u equal? What would u have to equal? So if whatever u is, and I squared it, and it came out to x to the 6th, u would have to be u cubed. And you can tell right here especially. Usually the coefficient of x, that's how you can tell what your u substitution is going to be. So right here I just wrote u equals x cubed. And I just save it up here for a while. You're not supposed to be able to see that yet. So letter B tells me to factor. So I just factor it, like I put the 9u squared in the bottom, and I put the 2 in the upper right. I multiply them together, and that gives me negative 18u squared. I put the 3u in the bottom here. And then I think of two numbers that multiply to make negative 18 and they add to make 3, so I came up with 6 and negative 3. Put them in my area model, and then I had to figure out what goes on the outside. So I ended up with 3u plus 2 and 3u minus 1. And that's the factored form of this quadratic. And then letter C in the book says, let me read what it says. It says, replace u with its equivalent expression so you can write the factored form of 9x to the 6th plus 3x cubed minus 2. So I had 3u minus 1, but I know u's x cubed, so I went 3x cubed minus 1. And then 3u plus 2 was 3x cubed plus 2. And then, if I want to check that, I can check it and rewrite it. So this would be 3x cubed minus 1 and 3x cubed plus 2. That's 9x to the 6th minus 3x cubed plus 2. 6x cubed and negative 2, and so that gives me 9x to the 6th 3x cubed minus 2. Okay, so those are the two things that we would have learned in 3.1.2.